Hello everyone, I, Wafa Wahida binti Junaidi, along with my group members, Nurul Ayu Fatihah binti Marzuki, Sharifah Jasmine Khatijah binti Syed Abdul Razak, and Siti Aisyah binti Sulaiman will talk about a question related to the topic in the calculus. Everyone knows mathematics was very important in our daily life. Without us realizing it, we have used mathematics in our daily life. So, in this video, we can see an example of how mathematics can be linked to our daily life. So, we are going to present a question related to the topic of the application of differentiation. So, the introduction for this topic. Related rates problems involve two or more variables that change at the same time, and possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used.
Problem statement. My birthday is coming soon. I would like to celebrate it with a party. I will prepare some snack for the food and white ready for the drinks, and it requires a lot of ice. So I decided to make my own ice. I poured water into 2 square containers with size 12 cm. On that day, I took out the ice containers from the fridge. Unfortunately, I have to go to the shop to buy some ingredients and I totally forgot about the ice. By the time I come back, the ice have melted. While I still have time, I will put the ice back into the fridge to freeze. But can the ice freeze to the size of the container back before the party begins?
Next, the objective is to determine the rate of change of two ice cubes to freeze.
This is the diagram for our questions. From the problem statement that stated before, the sides of the ice cubes are x centimeter. So we know that every sides of cubes are the same. So we put unknown, which is x, to represent the sides of the cubes. Also stated in the problem statement that the side of the container is 12 centimeter. When we pour water in the container, the water will take the shape of its container. By that information, we know that x centimeter is equals to 12 centimeter. By using all this information, we are going to solve the question which is rate of change of the ice to freeze in time before the party begins. That will explained by Aisha in the next slides.
Solutions. Given that the ice cube with the size of x centimeter freeze at a rate of 9.72 cubic centimeter per minute, find the rate of change of the two ice cubes to freeze. From the question, we know that the volume of the ice cube is x to the power of 3, and the rate of it to freeze, or freezability, is 9.72. What we are going to look for is the dx/dt, which is the rate of change of the two ice cubes to freeze. In the problem statement, we all know that the size of the container is 12 cm. So let's test the size of the ice cube. So here's the solution. v equals to x cubed, and now we have to differentiate the previous equation, which is dv over dx equals to 3x cubed, which is dv over dx equals to 3x to the power of 2. So from that, we get the dx over dv is equal to 1 over 3x to the power of 2. To get the dx dt, we have to find the dx over dv with dv over dt, which is 1 over 3x to the power of 2 times 9.72. Substitute the side of the container, which is 12, into x. So we get the answer of 0.0225. Now we got the rate of the change of one ice cube. To get the rate of change of two ice cubes, we need to times it 2, which makes it 0.045 centimeter cube per minute.
Lastly, for the conclusion, the rate of change for the ice cube to freeze were 0.045 centimeter cube per minute. I do not have to buy the ice from the shop because the ice will be able to freeze before the party begins at the night. That's all from our group. Thank you.